Okay, hi guys. So this is the notes for our central angles and arc measures. So the first thing we need to know is what arcs are, and then how to find their measure. All right, so we're going to start with four definitions here. The first is a central angle. So a central angle is any angle whose vertex is the center of a circle. Okay, so it's an angle whose vertex is the center of the circle. So, for example, we have angle ACE, right? That's an angle. Okay, that's a central angle because the vertex of that angle is point C, which is the center of the circle. Okay, so you would name this just like any other angle, angle ACE. Right? We could also pick a different angle. We could pick angle ECB. I'm sorry, ECF. So angle ACF. Right, but because the center of the circle is C, no matter which angle you pick, the middle letter is always going to be C, right? So this is DCF angle. DCF. Right, those are all central angles. They all have a vertex in the middle. Okay, so pretty simple there. Central angles, vertex is in the middle. Vertex is the center of the circle. Okay. Second definition, a semicircle. So a semicircle is half of a circle. Semicircle is half of a circle. Okay. Measures 180 degrees around. Okay. It's going to measure 180 degrees around. So an example of a semicircle, right? You have a diameter ED. So a semicircle could go all the way from D to E, right? That's half of the circle. So that's what we mean by a semicircle, right? ED is a diameter. Right, this line here is a diameter. Right, they tell us it's a diameter. It goes from one end of the circle to the other through the middle, so that's what a diameter is. So we have one arc on that side, or one semicircle on that side of the diameter. And then here we have another one. Okay. And the measure of a semicircle is 180 degrees. So 180 degrees. Right, and the red arc over here also measures 180 degrees. Okay. So to name a semicircle is an arc. Okay, so to name an arc, we're going to use 3 points on that arc. We're going to start with one endpoint, go through a point in the middle, and then end with another one. So if we look at the red arc here, our endpoints are D and E. So we're going to start there. So D, and we go around. We go through point F, through point B, and then to E. You want to pick one of the ones in the middle. So let's just pick F. Right, and then the other endpoint is E. So DF, E. Right, and then we put this arc symbol over top. Okay, so D and E have to be the endpoints of the arc. So D and E are the endpoints. And then you need to pick one point in the middle. It doesn't matter what it is. We could have picked B if we wanted to. Okay, point B is in the middle there. But you need to use the two endpoints, D and E, and then one point that's in between. So the semicircle DBE, goes from D to E through point B. Right? It's going from D to E through point B. Right? So that's how we name our semicircle. The green one goes on the other. It goes from D to E again, but this time it's going from right. So it's going from D to E. Right? But this time it's going through point A, so we have to do DAE. Right? And the purpose for this is, again, there's two ways to connect D to E on the circle. You can go through F and B, or you can go through A. So you need to specify by having that third point in there. In this one, we're going around this side of the semicircle, on this side of the circle, because we're going through point B. For the green one, we've got to be on this side of the circle because we're going through point A. Okay, so that's how you would name your semicircles. They're arcs that go, the red one goes from D to E through point B. You could switch the E and D, that would be fine. And then the green goes from D to E through point A, so DAE, arc DAE. Okay. All right, next one up is minor arc. So if a semicircle is 180 degrees, we then have minor arcs and major arcs. A minor arc is going to be less than 90 degrees. A major arc is going to be more than 90 degrees. Okay, so a minor arc is an arc that is less than 180 degrees. So less than 180 degrees. A major arc is an arc that is more than 180 degrees. So a semicircle is an arc, right? We said it was half a circle. We could have also said it was an arc that it's 180 degrees. Okay, so if you're less than 180 degrees, you're a minor arc. If you're greater than 180 degrees, you're a major arc. So let's look at some examples and some naming. Right, so minor arcs are less than 180. So an example of a minor arc would be DF. Right. So for a semicircle, we use 3 points to name our arc, our semicircle arc. For a minor arc, you're just going to use 2, and it's going to be assumed that you're going the short way around. So how we would name this would be arc DF. So we would say arc DF, right? And then we put the arc symbol over top. Okay, if we wanted to say the measure of arc DF was 60 degrees, we would say the measure of DF equals 60 degrees. Okay, so that's minor arc DF. That means the measure of minor arc DF. Okay, we could have done many other minor arcs too. Again, we could have done AE here. Okay, so AE, right, minor arc AE, that's the name of it. And then the measure of AE would be 45 degrees. Okay, so lots of different minor arcs on this diagram. All right, major arc is greater than 100. Oops. Okay, major arc is greater than 180 degrees. Okay, so if we were to start maybe at D, and instead of stopping at F, we kept going all the way around, right, all the way to A, that would be a major arc. It's more than 180 degrees. It's more than half of the circle, right? A circle is 360 degrees around. So if we're over 180, that means we're more than halfway. So again, your endpoints of your arc are D and A. So we can pick any one of these other 3 points in the middle to name our arc. So I'm just going to use F here. So arc DFA. Right? That means the arc's going from D to A through point F. So from D to A through point F, right, as opposed to going the other way. Okay. So that's the naming and the definitions there. Now we want to try and answer these questions in the middle and find these angle measures and arc measures. Okay. So the key here is that the measure of a central angle, right, the angles in the middle, is equal to the measure of the arcs on the circle. So the arcs are part of the circle, and their measures are going to be each equal to the central angle for those arcs. Okay, so let's look at some examples here. Okay, the measure of angle FCD. So FCD is this angle here, right? Angle FCD. Right, so the measure of the arc here is going to be equal to the measure of the central angle. So the central angle here is also going to be 60 degrees. So the measure of angle FCD is 60 degrees. Okay. So the arc that's associated with that angle FCD is going to be DF. Right. So here's arc DF. Its associated central angle is angle FCD. So the measure of arc FD is 60 degrees. The measure of central angle FCD is 60 degrees. They are the same. Okay. We can do the same up here with AE. So the measure of arc AE, it tells us, is 45. Right. So the measure of arc AE is 45 degrees. Okay. And we also therefore know the central angle is going to be this angle here. And it's also going to be 45 degrees. So the associated central angle with arc AE is angle ACE. So angle ACE. Okay. The measure of arc ADF. So at this point, what we want to do is we want to try and fill in our whole circle here. Okay. And the number one thing you want to look for are semicircles. Okay, so here we have a semicircle, right, from D to E. So we know the measure of a semicircle is going to be 180 degrees, right? So if we do 180 minus 60, right, because this is a semicircle. So 180 minus 60, we're going to get 120. So we knew that this angle measure right here and this arc measure are both going to be 120 degrees. And we can do the same thing on the other side with our other semicircle. So our other semicircle, right, was EAD or DAE. DAE. Okay, so we know that adds up to 180. So we can do 180 minus 45 is going to be 135. So we know that this angle here is 135 degrees. And we also therefore know that this arc here is 135 degrees. Okay, so that's like kind of how we filled everything in. We know a semicircle is 180, so we can do 180 minus 60 was 120, and 180 minus 45 was 135. Okay, now that we have all the pieces, we have everything we need to solve all of these questions. Okay, so the next one, the measure of arc ADF. ADF, so we're going from A to F through D. That means it's going to be this right here. Okay, and we already know the angle measures or the arc measures that make it up. And the arc measures are 135 and 60, right? So 135 plus 60, okay? 135 plus 60 right, is going to give us 195. So the measure of angle ADF is 195 degrees. Again, ADF, right? So we're simply adding the blue and the red here. Okay. The associated central angle for that, ADF, is going to be ACF. So angle ACF. Okay. Measure of AD, we've already filled that one in. So AD, arc AD, minor arc AD is 135 degrees. Okay. So the central angle there is ACD. So angle ACD. Okay. The measure of angle ACD. So we already have the measure of angle ACD. That's 135 degrees. And we just said the arc associated with angle ACD is arc AD. Next one is ACF, and the measure of angle ACF. So that's, we want to draw it in. Angle ACF is this angle here. So this angle incorporates the 45 and the 120. So we need to add those up, 45 plus 120. 45 plus 120. It's going to be 165. So we know the measure of angle ACF is 165 degrees. And the associated arc, right, is less, since it's less than 180, it's 165. We know it's a minor arc, so we're going from A to F. So it's going to look like this from A to F. Okay, and we'll name it AF, right, with our arc symbol on top. All right, two more. AFD. Oops. We wrote stuff without deleting anything. All right, so it was 165. And again, we were going from A to F, so we said A, F with a line over it. Okay, AFD, the measure of arc, AFD. So AFD, so we're going from A to D through F. That's going to be this way. Okay, and all we got to do is find that angle measure, is add up the three parts. So 45 plus 120 plus 60. So 45 plus 120 plus 60. So 45 plus 120 plus 60 is 245. So the measure of arc AFD is 245 degrees. Okay, AFD, so the associated angle is going to be ACD. Okay, and then last one, FDE, arc FDE. So we're going around this way from F to E through point D. So ADF is going to look like this. Right, so all we got to do is add up the three angles together. So 45 plus 135 plus 60. So 45 plus 135 plus 60. Oops, didn't mean to do that. So that's going to be 10. 8 plus 6 is 14. So 240 degrees. Okay, FDE. And so your central angle there is going to be FCE. Okay. And so it does get a little confusing because in terms of the central angle, the name of this angle, FCE, is the same as the name of this angle, FCE. So the central angle kind of gets confusing because it's really a central angle for two different arcs, the minor and the major that it's associated with. I don't think we really need to worry about that too much. Okay, so those are the notes. Central angle equals the measure of its arc, and vice versa. And we can use that information to solve. The number one thing you're going to use to solve here, though, is semicircles. So semicircles are going to be very common in the problems you'll be working on, and you have to use that along with vertical angles to solve for this, all the central angles and all the measure of the arcs. But that's it for the notes here.